right, guys, we're over halfway now. You've done 4 sections. You've taken a quiz on them. You've done well on your homework, and your discussion posts are going well. So today is measure a center. It's how close things are to the middle and how spread out they are. I kind of like this section. It's more like stats. So when we go here, measure a center is the middle. So that's what we write here. It means the middle. What are we looking at? There's 3 main ways to find the middle. Mean is the average, median is the middle value, and mode is how many occur the most. You've used those for a long time. I'm going to add a symbol to you. This symbol right here is mu, and you start down, you draw a tail up, and kind of like a little U. That means mu. It stands for mean when you see it in an equation. All right, the first thing I want you to do is this, the first one. So pause, put them in order, and let's see if you can find those 4 things. So I put them in order already. I added them up. So 471 divided by 9 is your mean, which is 52.3 repeating. Your middle was the 53. Then you had 2 modes. This one here is known as bimodal, 51 and 58, and that's totally possible. Okay, now we're going to go to measure a center, or measure a variation, and there's 2 different kinds of absolute value deviations we're going to find. We're going to do a mean absolute value and then a standard deviation later. The mean is used sometimes. It's not as accurate, so it's not as often, but it's faster. So measure a variation describes how spread out your data is. So are they close together and really good, tight data? Are they really spread out and all over the board? Okay, to do this here, the mean absolute value, you find the average distance of each value to the mean. So here's my formula. This means x is the number you're using minus mu, which is your mean, remember from above. You take all of those absolute value, you add them up, that's what summation means, and then you divide it by how many you have. So step 1 in this mean absolute deviation is we have to find the mean. So we know our mean is you add all these numbers up, so add those up, divide by 6 because that's how many we have, and our mean is going to be equal to 79.83. So now to calculate this, I have to take every number minus 79.83. So we go down here. So I'm going to take 85. So you're going on your calculator, you're typing in 85 minus 79.83. Whoops. 83. And when you do that, you get 5.17. Now you're going to add, now take 74 minus 79.83. Well, when you do that, you get a negative number, but the absolute value means I write it in as positive. So now you're taking 74 minus 79.83, the absolute value of that, and you're writing it down, which is 5.83. Plus, now you do the same thing with 88. So 88 minus 79.83, absolute value is positive, 8.17. Okay, pause and do the other 3. So 0.17, 12.17, 19.83. Add those up, divide by 6, and you should get 8.56, which is your mean absolute deviation. All right, I'm not going to do yours, but I would like you to try. I will give you the answer though. You should have came up with 2.6 and see how you do. All right, next one, variance and standard deviation. These 2 are used the most. This is what I am used to using a lot. The variance is just the standard deviation squared. So it's not too hard to find. A lot of times we find the variance, actually I find the standard deviation and I square it to find the variance. This one here is saying you take your number minus your mean, you square it, add them up, and divide by your total. And that gives you your standard deviation squared. Take the square root and you get your standard deviation. I know that sounds really difficult, but it's really not too bad. Okay, the variance is the average squared distance. So the average squared distance, because that's why we got the squared here, to the mean. And then the standard deviation is the square root. So this is just the square root of the variance is what we want in here. Okay, lower standard deviation means that values are close together. So if I have a very small number, my data set is close. If I have a very large number, they're very spread out. So depending on what you're doing, depends on what you want. Generally, you want them close together. You want a smaller number. Okay, let's try one out here. Let's do a small one. Okay, so when we go here, we have our 4 numbers. Our first thing is we have to calculate the mean. So we add all those up, we divide by our 5, and we get our mean is 92. Step 1, find the mean. So now that we have the mean, we take to find the variance. So we're doing, so it goes like this, by the way. Variance squared, so variance is this symbol right here. Okay, so to find the variance, we take every number minus the mean, so 85 minus 92, whoops, and we squared, plus 88 minus 92, and then we squared, plus 91 minus 92, and we squared, plus 96 minus 92, and we squared, plus 100 minus 92, and we squared. Then we take that answer and we divide it by our total, which is 5. Plug that in your calculator, and your variance should have been 29.2. Now, you take, to find your standard deviation, which is this symbol, you take the square root of 29.2 to get your standard deviation. So 29.2 is here. Standard deviation should have been 5.4. All right, we're not going to do a ton of numbers here because this takes forever. I want you to do number 6. So pause and try this and see how you do. I thought I'd show you how I usually do this. I take and I find my mu, or my standard deviation. Okay, then when I do that, I take and I write down all my numbers on the side here. So my column 1 is just my numbers. I subtract out my standard deviation and get my numbers here, and I square them over here. This last column, I add up, and then I divide that number by 9, which, well, by the number we have, which is 9 this time. When you do that, you get 23.65, depending on how many decimals you went out. Square root of that is 4.86, and you are finished. I hope you did well. All right, the next thing I want to talk about is what a standard deviation curve looks like and how to read it. So when you look at this thing, a bell curve is usually what we consider normal, all right, our normal curve or a bell curve. Okay, when you look here, these are skewed. So like this guy is skewed, and this guy is skewed, and this here's a normal bell. So this is my bell. This is skewed to the right because he's got more on the right, and this is skewed to the left because he has more on the left. Okay, a symmetrical bell-shaped curve is what we're talking about here. This is what we're going to be using. It's defined by the mean and the standard deviation, okay, of the data set. Now, the area under the curve represents the probability with a total area equal to 1. So like where I am under the curve is a probability that this will happen, and the total area under the curve, so like from here to here, is always equal to 1. One standard deviation. So a standard deviation is how far I am from the mean. So right here is the mean, right in my middle. Okay, one standard deviation, which we're going to calculate, can go to the left or to the right. So the odds that I am 1 standard deviation away is 68.2%. 2 standard deviations away. So from here to here, so I'm getting farther away. How my odds I'm going to fall in this area under the curve is 95.4. And the odds that I'm going to fall 3 standard deviations away is 99.8. Okay, this is on a perfect bell curve. Later on, we'll learn how to calculate that if you go into other classes. So you got 68.2, 95.4, 99.8. All right, so in your curve, these percentages are not going to change for us. So between mu and 1 standard deviation, so you take 68.2 divided by 2, and you get 34.1. So 34.1 on both sides. That will always be 34.1. You are going to want to remember that. You have 13.6 left here. So if I take 95.4 minus 68.2 and divide it by 2, I get 13.6. So you take 95.4 minus 68.2, take that, divide it by 2, so that's, what is that going to be, 27.2. Divide that by 2, and you get 13.6. Okay, the next part on the outside, this is going to be 2.2 right here. Okay, this curve is a little deceiving because this actually goes on forever. You just cannot tell the difference. And that there is 0.1 in this forever part. Those numbers do not change. That's what we're going to use to figure these things out. So when I have my standard deviation, I can immediately write in 34.1, 13.6, 2.2, and 0.1. This is going to help me determine how to figure this out. Okay, now the weights of 50 football players are normally distributed. That's important. That means I can use these predetermined numbers. A mean of 178. So mean is right here. So the average is 178 pounds. A standard deviation of 8 pounds. So that means every 8 pounds away is a standard deviation. So I take 178 and I add 8 and I get 186. I add 8 again, I get 194. I add 8 again and I get 202. This is a very small football team. Probably not accurate. Subtract 8 here, we have 170 pounds, 162 pounds, and 154 pounds. Okay, I have my curve filled out. Now, what percentage of the player's weight between 178 and 94? So I'm looking from here to here. So all I do is I add these up. So I take the 34.1 plus the 13.6, and that says I have a total of 47.7% of my players weigh there. What's the probability that a player weighs at most 170? So that's 170 or less. So this guy all the way down. So I've got to add all those up. So if you need to plug these in, please do. 34.1, 13.6, 2.2, and don't forget your 0.1. So from 170 down means I have to add the 13.6 plus the 2.2 plus the 0.1, and that probability will be 15.9% that they'll weigh that much. What's the probability that a player weighs less than 162? Let's go up here. So less than 162, so that's these directions. So we got 2.3 right now. Let's write that down. And greater than 194, plus 194 is also from here to here. So that's your other side of the spectrum. So we're going to have a 4.6%. How many players weigh between 170 and 186? Okay, now this is a trick question. I want to know what's here. It is not asking for the 34.1%. It said how many players. So that means I have to take my total football players, which was 50 from up here, and multiply it by your 0.341, and you're going to get 34 players. Remember, you cannot have a partial player. So do not write down 34 point something. Okay, let's see, which one do we want to do? Which one's more interesting? Let's just do the top one and we'll skip the other two. Okay, pause and try yours. Okay, I hope you did well. So you should have taken 120 test scores. 82 was your middle. Standard deviation is 5. So you added 5 going this way, subtracted 5 going this way. Percentage between 72 and 87. So you're between 72 and 87. You had 2 34s and a 13, giving you 81.8. Okay, greater than 77. Well, I know 82 is halfway, so it's 50. So this is all 50 here, plus the 34.1. If you add them all up, you still got the same answer of 84.1. Okay, probability the score is less than 82 or greater than 92. So less than 82 is 50% again, because 82 is my middle. Greater than 92 is this last two tails here, which is 2.3, giving you 52.3. Okay, this one again was you had to multiply when you were done. So it's asking you about actually the two tails. So 92 is the 2.3 because the 2.2 and the 1. 72 is also the 2.2 and the 1, giving you 4.6 total. So you take 120 times your 0.046, which should have given you 5 students because you can't have a partial student. Nicely done. All right, it's homework time. Do them until you feel comfortable. I would not expect you to do all of these. Some of these get rather large. So, but at least do one with money in it and at least do one with a few more numbers. So good luck. Do the other page and post your questions.